Hello friends, this is Praveen and today we are going to learn about the metals and non-metals. So what are metals or what are non-metals? So in history classes we have learned about the different types of ages such as Stone Age, Iron Age, Bronze Age, etc. In the Stone Age we used stones. The stones which were sharpened and used for hunting and hunting animals for the food. But in fact, what did the early man? They once found a special type of a rock which changes its properties. So first, when he hit against another stone, it makes up a clanging sound, which helps him easy to find out. But when he started hitting it with another rocks, he can see that another rocks break, but that rocks doesn't that is breaks, but it does something interesting is that it changes its shape. So then he go in the fireplace and then he once try an experiment that what happens if I burn this. So burning that he sees that it is coming turning into a vapor of stone that turns into water, but we know that it exactly is not water. So what is this kind of rock? So these the which properties which I have mentioned of the stones which gave the rise to the Iron Age and then to the Bronze Age is known as the metals. And what are non-metals? Stones that do not follow this property are known as non-metals. So we can instead of saying it stones, the technical definition of this would be the using the elements. So first, what are the different properties of these metals and non-metals? So what are the different properties they follow? So first, we are going to discuss about the physical properties and then we will move to the chemical properties. So first we have is the physical state. So how do we know that it is used for hunting or it can be for our beneficial for the upcoming ages? So if we will write this non-metals and we have so first it must be solid. So by the physical state I mean that a substance must be solid at the normal room temperature. So mostly all the metals are at solid at room temperature. But it is not the case. In the case of non-metals it could be solid or either gas in the form of gas. So there are few exceptions. For the metals, it is mercury, which is states in the liquid temperature at the normal room temperature. That is liquid state in normal room temperature, and in non-metals, the bromine is a type of element which stays at the liquid form at the normal room temperature. So next we have is luster. So what is a luster? A luster means how much amount of light it is reflecting back. So if you will take a substance such as the iron that reflects lot of light back, but if you will take the plastic, it doesn't reflect most of the lights. So metals have the another property that they are lustrous. So they have good luster, but non-metals in fact have not luster. That means they have not luster. So there are a few exceptions in which the luster, if you will take the sodium at the when it is exposed to air, it loses its luster. And for the that is non-metals which is not lustrous, we can take the examples of the diamond, that is coal and graphite. They are very shiny, and in fact the iodine also is a shiny or it has luster. So now we have is hardness. So what is in hardness? How hard is the material? In the case I have told you that a substance when we take the stone, a different kind of stone and hit with, it doesn't break. The another stones break, but it doesn't break. So this is the hardness. So the metals are very hard, and the non-metals in fact are not hard. So the non-metals, another than the diamond, which is also a form of a carbon, is very strong. This is the not included in that. So now we have is malleability. So we know that when we hit with a larger rock, the stone in fact changes its shape. So what kind of shape? So if we will take, for example, if we have this rock is in 3D form, and now I am waiting to form it into the 2D. So this is known as malleability. And when this 2D I in fact beaten from 2D to 3D or 2D to 1D, I got this ductility. So what is the malleability? The malleability is the capacity of the metals to be turned into the sheets. And ductility is in fact the wires turning into the thin wires. That means a same straight line. So for the metals and non-metals, they are malleable, means they can be turned but they are not. Not they are not malleable. And for the examples of the malleable, there are the stones like copper, iron, the bronze, etc. But these are not examples of these. Would be the carbon and carbon, iodine, etc. And they are for the turning into the 1D, we have is ductility. They are good at ductility, but they are not ductile. So, examples of these would be copper, which is used in the wires to transport electricity, and these are, for example, would be iron also to turn into the iron nail. So now we have is a brittleness. So what is a brittleness? A brittleness is in which we see the rock doesn't break, but what happens if a rock breaks? So this is the mainly a category characteristics of a non-metal. So it is brittle, whereas non-metals are not brittle. So they are not brittle. Now we have is the thermal conductivity. What is the thermal conductivity? The thermal conductivity is the how much heat it can transfer. If I am applying some unit of the heat to it, can how much energy could I get on the another end? This is known as a thermal conductivity. So we can see that metals are very good conductor. So we that is a conductor, so it allows the for the heat to pass it, but the most of the non-metals are insulator, so they don't allow the current that is the heat to pass through them. For the electric current, it is same for the thermal conductivity. The electric current, in which the word suggests electrics, so the substance which allow the electricity to pass through them. So it must have we know that from the electricity chapter that more the free ions, the easier the electricity can pass. So in fact we can conclude that the metals have the more free electrons than compared to the non-metals. So it is then this could be defined in the same statement, that is they are good conductors but the non-metals are insulators, that means bad conductors. So another property is sonority. So what is the sonority? We heard that the stone produces a different sound, that is a clanging sound. So this property that a metal produces a different sound, a clanging sound, is known as a sonority. So metals are sonorous but non-metals aren't. So thereby that's why many rings are that is the bells are made from the metals. Now let's move to the chemical properties. So what we have seen the physical properties. Now it must also follow the chemical properties. So one more that is for the competitive approach. that the metals have more free electrons than compared to the hydrogen. They have least amount or neither at all the free electrons, that is negative electrons. So what happens? These chemical properties can be seen with the help of the reactions with the different types of substances. For this grade, we are only taking these reactions with the oxygen, water, acid and bases. So first let's see with the acid. That is the oxygen. So what happens when we put the metals in that metal is exposed to oxygen, it forms the metal oxides. So if we take the magnesium, that is Mg plus O2, which forms the magnesium oxide, that is 2MgO. In the same way, if we will take the sodium, it would form the required sodium oxide, and it forms a respective type of oxides. So when we will add the water to it, because now they may be in the different forms, so we have to plus add H2O to make it a aqueous solution. We know from the acid bases chapter that we can test the aqueous solution whether it is acidic or basic. So when you will try with the different types of substances such like magnesium, sodium, etc., it would always be a basic. So we can conclude that basic, or that is the metal oxides, are always basic in nature. But it is not the case for the few metals, which are the aluminium and the zinc. So now these are, but what happens if we add non-metals? So non-metal, as we see, it is opposite of the metals. So they also form the oxides, but these oxides are the acidic in nature. Examples would be sulfur plus that is oxygen would be sulfur dioxide, which is acidic in nature. So nitrogen plus that is oxide, that is oxygen gives us nitrogen dioxide, which when turned with acid to form acid rain, that is nitric acid, and then with sulfur, which would be sulfur dioxide plus water, which give us sulfurous sulfurous acid or the sulfuric acid. So these were the reactions with the oxygen. What does the metals do with the oxygen? But what does it do with the water? So what does the metal do? When a metal is put into the water, it either forms the metal oxides, and or another it would form metal hydroxide, in which if it is forming the metal oxides, we are only taking the oxygen, means hydrogen is released. Plus when we are taking the hydrogen that is metal hydroxide, so in which both the components are used, so hydrogen gas is not involved. This property is that means the metals non-metals react easily with the water. So water, that is the metals like sodium and that is potassiums, help us are stored in kerosene, but when they are exposed to the air, in fact air contains the moisture, so it is enough for them to act vigorously. So they are very reactive, but the metals like the gold, silver, platinum do not react with all. But the some metals which are neither not too reactive but not less reactive, so these are just like iron, copper, zinc. So they can react with the steam of that water, because they react with the high temperatures. But they, as I told you, that silver, gold and platinum do not react with the water at all. Same with the case of the that is the non-metals. It doesn't react with that. If it reacts, it forms the metal that is oxides, that is non-metal oxides or the metal hydroxides. The hydroxide stands for the base, that base. So metal when added with a base can non-metal added with the water can form base. So now we have talked about the oxygen and the water, but what of them if they are exposing to both? These forms due to the corrosion. So what exactly is the corrosion? You may have seen when an iron object is placed outside, when it is exposed to both oxygen and the water, start forming the rust. So this rust, so this is known as a corrosion. example, in the copper itself, we see the when it is exposed to it, the green that is copper is a brown in color, but it eventually start becoming green in color. This is because of the formation of the copper carbonate and the copper hydroxide. So these were the, in fact, the silver also get corroded sometimes. It forms a black the black reddish cover on its surface. For example, the gold also corrodes as well as platinum. So you have to wash it with the HNO, that is aqua regia solution, that is the solution of HCl and HNO3. So now what reaction with acid? So we know that the metals are acid, that is basic in nature. So what happens if they will add into the acid? So they would produce the salt plus water plus the hydrogen gas would be liberated in the system. Whereas if you will take the reaction with acid plus that is non-metals, which is all acidic in substance, so it doesn't react with all, but some mostly they react with very concentrated acid which is that is HNO3 or H2SO4 or even HCl. So they react with the high pH of the acids. So these were the reactions with the acids. So what is the reaction with base? In fact, this the metal was base, so it doesn't react with the base. So metals doesn't react with mostly as a base, but as then acids do, which is the non-metals. So what does they do? They forms the that is the salts plus water, and the respective salts plus water and the hydrogen gas is liberated. So now the another property is the displacement reaction. So what is the displacement reaction? This displacement reaction only works for the mostly works for the metals, and it can work for the non-metals. So if I will take example, the copper sulfate solution. So if I have a copper sulfate solution in a beaker and I drop the copper, uh, I have dropped copper, it would create no difference. But in fact, if I drop this zinc, you will notice that the color of the solution starts changing, and there is a brown color deposition in the bottom of the beaker. So this is a because zinc is more, so we have a zinc then more reactive than copper. So this causes the copper sulfate solution to displace with the zinc, and so it forms a zinc sulfate solution, and the copper sulfate molecule, that is modules, are left at the bottom. So now if we will take for the example of the iron, also iron would do the same with the copper sulfate solution, but this means that iron is also that is Fe is also reactive, but which is the more reactive? So for this you can conduct or create any solutions, if that is zinc sulfate or the iron sulfate, and put the that is zinc or iron respectively to form, if they are which is more reactive. In this case it would be the zinc would be more reactive. So we have the series as C2, Fe and Zn, and these that is silver, that is gold and the platinum are the least reactive, but whereas sodium, potassium, these are the most reactive. So now where are these acids bases used? So for the metals it is mostly used in the for the most it is used for making the instrument, just like batteries, for the steel bodies or for the cars, and more different types of alloys can be formed with the help of the metals because they are very hard. But for non-metals such as chlorine, it is used to kill and purify water. In fact, oxygen is non-metal, so which is noble gases. Oxygen uh, is help us for the welding of the materials with the help of the another gases, plus it is essential for the living organisms. Same as the nitrogen, it is used in the fertilizers for the crops and etc. So friends, let's summarize what we have learned today. We have started learning what are metals and non-metals, what are the different properties, that is the physical properties and the chemical properties. So physical properties include physical state, lustrous, hardness, malleability, ductility, brittleness, thermal conductivity and electric conductivity, and and snow ready. For the chemical properties, we have seen the reaction with oxygen, water, both with oxygen and water, and then with acid and bases, and we see the displacement reactions, and we also see where are these metals and non-metals used. So friends, I hope that this chapter is clear to you, and at the last, thanks for watching.